So we continue using the simplex method. We'll solve this linear programming problem using the simplex method. And it says, a sporting goods store has requested a fabric manufacturer to produce jogging pants and matching pullovers. For materials, the manufacturer has $800 of wool textile, $500 of nylon fabric, and $650 of polyester. To manufacture every pair of pants requires $2 worth of wool, $2 worth of nylon, and $3 worth of polyester. Every matching pullover requires $4 worth of wool, $2 worth of nylon, and $2 worth of polyester. The cost for a pair of pants is priced at $50, and the matching pullover is priced at $40. Determine the number of pants and pullovers the manufacturer must produce for the sporting goods store to maximize its profit. What is the optimal profit for the manufacturer? So the first thing we'll do is to determine the objective function. And we could see right here we want to maximize the profit. We want to maximize its profit. So that's going to be the variable P for maximization, and it's the profit that we want to maximize. So we'll put it right here. And the profit is going to depend upon the number of jogging pants that are made, and of course the pullovers. And each pair of jogging pants is worth $50. We can see it right here. And each pullover is worth $40. So if we let the jogging pants be X, then we can write this as 50X. And if we let Y be the pullover, then we would have 40Y. So here's our objective function. The profit is equal to 50X plus 40Y. So the next thing is to express the linear equations with slack variables that represent the problem. And we'll do that by building a table. So we could see right here we want to determine the number of pants and pullovers. So that's going to be our variable. That's our unknown. And we know in our table, our variable is going to go across the top of the table, creating these columns. And then for the rows, those are the items that interact with the variables. And that is the wool, the nylon, and the polyester. Of course, also in our rows are the totals. So we have $800 worth of wool, $500 worth of nylon, and $650 of the polyester. So now that we have all the items, our table should look something like this. So here are our variables across the top, our pants and our pullovers, creating these columns. And here's each linear equation that's going to be generated, as we can see here. And of course, we also have our objective function along the bottom here, our profit. But right here are going to be our equations. So we'll write our equations with the slack variables. So we'll have 2x plus 4y. Then we'll put in a slack variable. We'll use u, and that's got to be equal to 800. Then we have 2x plus 2y with the slack variable, but it's got to be different than this equation here. So we'll use v. That's equal to 500. Then we have 3x plus 2y plus a slack variable. It's got to be different than the other two, so we'll use w, and that's got to be 650. So then we also want to include our objective function here, our profit, but we have to rewrite this so that all the variables are on one side of the equal sign, then it's equal to 0. So then we'll write this as negative 50x minus 40y plus p, and that's going to be equal to 0. So now that we have all of our linear equations with slack variables and including our objective function, we could go ahead and build the simplex tableau from here. So we'll put in our bracket. We'll label this x, y, u, v, w, and p across the top of our tableau. So we'll put in 2, 4, 1, we do have a u slack variable, no v slack variable, no w, no p. Put in our vertical line, and 800. Then we have 2, 2, no U, but we do have a V. And then 500. 3, 2, no U, no V. We do have a W. And then 650. And then for our objective function, -50, -40, 0, 0, 0, 1 for P, and then 0. Close off the matrix, and then put in our horizontal line. So now we have the simplex tableau that represents this problem. And the next thing that we're going to do is we have to determine our pivot element. Now recall that the initial pivot element is found in the column with the most negative value in the last row, and that's -50 right here. So this is going to be our pivot column. And then our pivot row is going to be the one with the smallest non-negative ratios. So we have 800 divided by 2, that's 400. 500 divided by 2, that's 250. And 650 divided by 3, that's 216.67. So 3 is going to be our pivot element. So we're going to change this column into a unit column using our elementary row operations. So we can take 1/3 of row 3, put in our bracket. 3 times 1/3, that's 1. That's the whole idea, right? 2 times 1/3, that's 2/3. 0 times 1/3, that's 0. 0 and 1/3, 0. 1 times 1/3, that's 1/3. 0 times 1/3, 0. Put in our vertical line. 650 times 1/3, that's 650 thirds. We can close off the tableau and then fill in the rest. So now we could target any of these other values within the column here. How about if we start right here? So we'll take row 1 minus 2 times row 3. Put in the bracket. 1 times 2 is 2. 2 minus 2 is 0. Again, that's the whole reason. 2/3 times 2, that's 4/3. 4 minus 4/3 is 8/3. 0 times 2, that's 0. 1 minus 0, the 1 stays. 0, 0, and 0. 1/3 times 2, that's 2/3. 0 minus 2/3, that's negative 2/3. 0, 0, and 0. Bring down our vertical line. 650 thirds times 2 is 1,300 thirds, and 800 minus 1,300 thirds is 1,100 thirds. Close off our bracket, and we can fill in the rest. So now we could target this element here. So we'll take row 2 minus 2 times row 3. And we'll start it over here. 1 times 2 is 2. 2 minus 2, 0. 2/3 times 2, that's 4/3. 2 minus 4/3 is 2/3. 0 times 2, that's 0 and 0. 0 and 2, that's 0, and then we have 1. 1/3 times 2, that's 2/3. 0 minus 2/3, that's negative 2/3. And of course we have 0, 0, and 0. Bring down our vertical line. 650 thirds times 2, that's 1,300 thirds. And 500 minus 1,300 thirds is 200 thirds. Close off our bracket, and we fill in the rest. Bring in our horizontal bar. So finally we could target this element here. So we'll do row 4 plus 50 of row 3. So we'll put in our bracket. 1 times 50 is 50. Negative 50 plus 50, that is 0. 2/3 times 50, that's 100 thirds. Negative 40 plus 100 thirds, that's negative 20 thirds. 0 and 50 is 0, then 0, so we carry that over. 0, 0, and 0, carry that over. 1/3 times 50, that's 50 thirds, and 0 plus 50 thirds, that's 50 thirds. 0 and 50 is 0, so we can bring down the 1. Put in our vertical line. 650 thirds times 50 is 32,500 thirds. And 0 plus 32,500 thirds is 32,500 thirds. We'll squeeze it in there. How's that? Close off our bracket, and then we can fill in the rest. Carefully put in our horizontal bar. So we've now changed this into a unit column. Step 3 says then we have to check, and we check by seeing if there's any negative values in the last row, and we could see that there is one right here. So we'll have to do this process over again. So this is our first iteration. But we'll continue with another pivot element. So again, our pivot value is going to happen in this column here. It's with our negative value in the 4th row here. So it's going to happen in this column. This will be our pivot column. Then if we take 1,100 thirds and divide that by 8 thirds, that's 137 and a half. Then 200 thirds divided by 2 thirds, that's 100. And 650 thirds divided by 2 thirds, that's 325. So then our pivot element is going to be 2 thirds. So then we could take 3 halves of row 2, put in our bracket. 0 times 3 halves, that's 0. 2 thirds times 3 halves, there's our 1. 0 and 3 halves, that's 0. 1 times 3 halves, that's 3 halves. Negative 2 thirds times 3 halves, that's negative 1. 0. And then we can bring down our vertical bar. 200 thirds times 3 halves, that's 100. Close off our matrix, and then we could fill in the rest. So now we can go ahead and target either one of these values here. We'll take the 8/3 up here. So then we'll take row 1 and we'll minus 8/3 of row 2. Put in our bracket. 0, 0, and 0. 1 times 8/3 is 8/3. 8/3 minus 8/3. There's 0. 0, 0, and that'll be 1. 3/2 times 8/3, that's 4. And 0 minus 4 is -4. -1 times 8/3, that's -8/3. -2/3 minus -8/3, or in other words, -2/3 plus 8/3, that's 2. 0, 0, and 0. Bring down the vertical bar. 100 times 8/3, that's 800/3. 1100/3 minus 800/3, that's 100. Close off the bracket, and we fill in the rest. Put in our horizontal line. So now we can target this element here. So we'll continue down over here. So we'll take row 3 minus 2/3 of row 2. Put in the bracket. 0 times 2/3 is 0, so then we bring down the 1. 1 times 2/3 is 2/3. 2/3 minus 2/3, there's our 0. 0, 0, and 0. 3/2 times 2/3 is 1, and 0 minus 1 is -1. -1 times 2/3 is -2/3, and 1/3 minus -2/3, in other words, 1/3 plus 2/3 is 1. Then we have 0, 0, and 0. Bring down our vertical bar. So 100 times 2/3 is 200/3, and 650/3 minus 200/3 is 150. Close off our bracket, and we fill in the rest. Carefully put in our horizontal bar. And finally, we have this last element here. So then we could do row 4 plus 20/3 of row 2. Put in our bracket. 0 and 20/3 at 0. There's our 0. 1 times 20/3 is 20/3. -20/3 plus 20/3. That is 0. That's the whole idea. 0 and 20/3 and 0. We have another 0. 3/2 times 20/3. That's 10. And 0 plus 10 is 10. -1 times 20/3 is -20/3. And 50/3 minus 20/3, that's also 10. 0, 0, and bring down our 1. Put in our vertical bar. 100 times 20/3, that's 2,000/3. 32,500/3 plus 2,000/3 is 11,500. Close off our bracket, and then we fill in the rest. Put in our horizontal bar. We now have our unit column here. Step 3 says, check to see if there's any negative values in the 4th row, and there aren't any, as you can see. So then we are done. So this was our second iteration. So this only took 2 iterations. Now, if we go back to the original question, it says determine the number of pants and pullovers the manufacturer must produce for the sporting goods store to maximize its profit. So here is X. X represents the jogging pants. X is equal to 150. So X is equal to 150 pairs of jogging pants. Here's our Y, and Y was our pullovers. And Y's got to be 100. So Y has to be 100 pullovers. And the original objective function was P was equal to 50X. X again is our jogging pants plus 40Y. And 40Y again was our pullovers. So then P is equal to 50 X, and of course X is 150 jogging pants plus 40Y, and Y is our pullovers, and that's 100. 50 times 150 plus 40 times 100. That's 11,500, which of course is what we have right here. So what is the optimal profit in order to maximize this for the manufacturer? If they make 150 pairs of jogging pants, 100 matching pullovers, the maximum profit will be $11,500. And that's it.